All right, here's some questions that deal with both permutations, combinations, and a bit of trigonometry. First question here says, how many six-letter codes can be formed from the letters A, B, C, D, E, F, G, H with repetition? So if you can repeat, then it's not a permutation. Permutations are arrangements of objects, no repeating. And so what you do is just figure out how many letters you have. 1, 2, 3, 4, 5, 6, 7. There's 8 of them. And so if you need to do a six-letter code, 1, 2, 3, 4, 5, 6, there's your code. You can put 8 letters there, times. If they said no repetition, then you'd put a 7 there. And it would actually be a permutation. But with repetition, you can say, well, yeah, I can put 8 there too, and 8 there, and 8, 8, and 8. So your answer would be 8 to the 6th, whatever that number comes out to. Second question, similar kind of thing, says you've got an 8-digit account. So 1, 2, 3, 4, 5, 6, 7, 8. 8 digits. Where the digits 1 through 9 are used, how many different account numbers can there be? No restrictions, same thing. So if you've got 9 numbers, there's not 10 because you can't use 0. So 9 numbers, so there's 9, I can go there and there, etc. So if I can repeat them, so the answer to this one would be 9 to 8th. You could figure that out on a calculator if you want. Okay, and this is basically the fundamental counting principle, which says figure out how many ways you can do this thing, figure out how many ways you can do this thing, and to figure out how many ways to do both of them, you multiply. And so if there's 8 of them, you multiply all 8. Okay, these questions deal with cards. And they say, when a single card is drawn from an ordinary 52-card deck, find the probability of getting a black 7. Well, there's 52 cards, and then you just have to figure out how many black 7s you have. There's one there and one there, so there's 2 of them. So 2 out of 52, or if you simplify, that'd be 1 out of 26. Number 19, card drawn from a deck, what's the probability they'll have a value of 4, and what's the probability that the card will have a value of 4 and be a face card? Well, here's the 4s, here's the face cards. You can't have the same thing. You can't have a number 4 on a face card. So you can't. There's no way you can do that. That's 0 out of 52. Suppose 5 cards are drawn from a deck of 2 of 52 cards. What's the probability of drawing 5 queens? Well, here's your queens. There's only 4 of them. And so there's no way you can do that. So that would be 0 out of whatever. It doesn't matter. I guess your probability would just be 0. Okay, lottery. You can pick a number from 1 to 46. If the numbers match, the player wins. So you figure out your total ways of doing something on the top and the total ways of something happening on the bottom. This one, we're choosing. Doesn't matter what order they come in. So on the bottom, I'd have 50 or 46 choose. We get to pick 4 cards, so 4 cards. And then this guy, he gets 3 tickets. So he's got 3 different ways to do that. So figure out what 46 choose 4 is on the calculator. Put that number here and 3 over that, and you might be able to simplify. Next question. Ooh, some trigonometry. I won't do all of these. I'll maybe just do 28. So 28. So it says the cosecant of an angle is equal to 12 over 5. Well, I know cosecant is reciprocal of sine. So if cosecant is 12 over 5, then the sine of an angle has to be 5 over 12. You flip it over. Now, they're asking me for cotan, and cotan is reciprocal of tangent, and tangent is opposite over adjacent. So cotan is adjacent over opposite. Sine over here, sine, the top one, is opposite over hypotenuse. So I have the opposite number right there. It's a 5. So my opposite number is a 5. But I don't have an adjacent number. I have an opposite and a hypotenuse. But I know I can use Pythagoras, which says the adjacent squared plus the opposite side squared is equal to the hypotenuse squared. Or you could write it as a squared plus b squared equals c squared. So if the hypotenuse is 12, so 12 squared, opposite is 5, 5 squared, adjacent side I don't know. Okay, whoops, that should be a plus there. So 5 squared is 25, 12 squared is 144, adjacent squared. And then move the 25 over to the other side, so adjacent squared is equal to, what is that? 119? Is that right? Can't think. 25, 4, 1. Yeah, that's right. So adjacent side squared is equal to 119. So just the adjacent side, if you take the square root of both sides, is the square root of 119. So that's what I can put right there. So the cotan is the square root of 119 over 5. And the other questions are similar to that one. This one's fairly easy. You just flip things over. Okay, here's another question. Convert this decimal, or convert two decimal degrees. So you can have degree minutes seconds, which we commonly call DMS, or you can have decimal degrees. Okay, now DMS stands for degree, minutes, and seconds. The symbol for minute is just one circle. The symbol for seconds is two little dashes like that, or slashes. What am I talking about? Sorry. The degree is a circle, minutes is one slash, seconds are two slashes. So if I look at my question here, it says 52 degrees. It doesn't give me a minute, so I'm just going to put a 0 in there for the minute, and then 37 seconds. So they want me to convert this to a decimal. Well, oh shoot, there I did it again. That shouldn't be a degree, it should be a minute symbol. So if they want a decimal, it's like, it says 0 minutes, which is hardly any. So I'm calling it 52.0 something or other. But I can figure out what that is exactly because the relationship between each of these is 60. So if I take the seconds and divide it by 60, that'll give me how many minutes I have. Let me do that on my calculator. 37 divided 60. 37 divided by 60, okay, is that. So if I divide it by 60, I'll have 52 degrees, and then 0.61, and it's 6 repeating minutes. Okay, see, so what I did is I took the seconds, divided by 60, and when I do that, that gives me minutes, and then I just add that onto the 0. Okay, now I'm almost there, but now I have to convert these minutes into degrees. So again, I take this number and divide it by 60, and I'll add it to this number. So I've got my number there. I have to divide that by 60. And so it gives me, and I add it to the 52. So 52.01027 repeater degrees. So 52 degrees, 0 minutes, 37 seconds is the same thing as 52.01027. Okay, so that's how you can convert from DMS to degree. Okay, here's a couple other questions. Well, I can do one of these. This is where you go backwards. So this time I've got 23.865 degrees, and they want to convert that to DMS. So I've got to have like 23 degrees, something minutes, something seconds. That's what they want. So this time, instead of dividing by 60, I'm going to multiply 60. So I'm going to take the 0.865 and times it by 60. Okay, 0.865 times 60, go. 51.9. Okay, so that will be 23 degrees, 51.9 minutes. Now I can take off this 0.9. Oh, did you notice I did that? I took this portion I left the 23 alone. I just took this portion and times it by the 60. And that gave me this. Now I'm just going to take the 0.9 part and times it by 60. So 0.9 times 60, 54. So this will be 23 degrees, 51 minutes, and 54 seconds. So that's what that is equal to. Okay, now on your calculator, these ones, you just plug them in. I guess this one here, you'll have to convert that to decimal degree, unless your calculator has a DMS button. Some do. But they're basically just plug into your calculator. I guess maybe I'll do this cotan one. If I have the cotan of 50.1, problem is I don't have the cotan button on my calculator. I guess my calculator I do, but most people don't have the cotan button on your calculator. So what you have to do is change it to a tangent. And to get the tangent, you have to find the reciprocal of this. So the reciprocal will be 1 over the tangent of 50.1. Then I do that on my calculator. So 1 divided by tangent of 50.1 equals, and I'm getting 0.8361. They want 4 decimal places. Yeah, that's correct. Now let me just check. I want to make sure my calculator's not in a funny mode, because you can have radian mode or degree mode. Oh, no, mine's right. So the thing I tested was that I just hit the sine of 30, and if I get the sine of 30 as 0.5 or a half, then I know my calculator's in the right mode. Okay, these questions at the bottom might be interesting, and these are just calculator questions. I'll do this one. So it says the tan of an angle is equal to 3.379. So I want to know what theta is. I want to know what that angle is. So I have to get rid of this tangent. I don't just divide by the tangent, but I do the opposite of the tangent. So the opposite of the tangent is called the arctan. So I can arctan this side, and then that will cancel that out. But if I arctan the left side, I also have to arctan the right side. 3.379. And so on my calculator, I'll just do that. So arctan, and usually it's tan with a -1 button on it. The arctan of 3.379, 73.5 degrees. So that angle is 73.5 degrees. Oh, they say nearest hundredth. So that's 2 decimals, 51. 73.51 degrees. Okay, a couple more questions here. Next page. This one and the next page have a bunch of questions where they ask you to solve a right triangle. And to solve a right triangle, what they're looking for is all the sides and all the angles. I'm just going to maybe do this boat question, and there's another question on the next page that is very similar to those, but I'll just do one. I'll just do this boat question. So I've got a lake and I've got a boat. Nice boat. And there's a cliff. Okay, right there. And they say the angle of elevation to the top of the cliff, so that's this angle here, is 26 degrees 57 minutes. Then they say the base of the cliff, if the base of the cliff is 2651 feet from the boat, so this distance is 2651, they want to know how high that cliff is. First thing I would do is convert this into a decimal degree. So I'm going to take 57 and divide it by 60. And that gives me 0.95. So let me I'll draw the triangle again. So this angle is 26.95. This side is 2651. And they want to know what this side is over here. So this is my angle. So this side over here is my opposite side. This is the hypotenuse, which I don't care about. But this side then must be my adjacent side. If I have opposite and adjacent in play, then the ratio I need to use is tangent. Okay, so the tan of an angle, oh, I know what the angle is. Oops. The tan of the angle, which is 26.95 degrees, is equal to the opposite side, I don't know, over the adjacent side is your 2651. So I need to solve for opposite, so I'm going to multiply this side by 2651 and multiply this side by 2651. Okay, so 2651 times the tangent, whoops, the tangent of 26.95, go, good, 1347. So that opposite side, the cliff, is 1,347.84. Well, they want the nearest foot, 1348 feet. That's how high the cliff is. Okay, here's a balloon question. It's the same kind of thing. This one, and what do they say? How far is the headquarters from a point? So they want to know what this distance is. Now, with this one, this is called a transversal, this line. And so if this angle here is 86.10, or 86 degrees 10 minutes, then this angle here is also 86 degrees 10 minutes. So you can do the same thing as we did in the last question. Okay, in this one they say what are the exact circular values. As soon as they say exact, you want to be thinking about this table that I had you memorize. So the first thing you want to do is find out where that angle is on the unit circle. And so maybe I'll do this one. This is a good one. So it says the sine, what is the sine of negative 5 pi over 4? So negative means I'm going this way with my angle. I just have to figure out how far that is. And you can think in radian mode, or you can convert that to degrees. Let me convert it to degrees. So it's pi, so times 180 over pi. The pi's cancel. 4 goes into 180, how many times? 45 times? And 45 times 5. Is that right? I need to do it on my calculator. I think it's 225, the number, but 5 times 180 divided by 4. 225, yeah, I was right. So 225 degrees. So 225, so here I come, this is 90, this is 180, and then I have to go up a little bit more, right to there. And if I go 225 minus 180, that gives me what we call a reference angle. And that's the angle from the closest x-axis up to the angle. And if I subtract those two, I get 45 degrees. So the sine of negative 5/4 pi is the same as the sine of negative 225 degrees, which is going to be the same as the sine of 45 degrees, with an accompanying sign change if I need it. And now I just look off my chart. Sine 45 right there. So it's root 2 over 2. Now the sign, whether it's positive or negative, I can get from that cast rule. And the cast rule says this, that only cos is positive, all are positive, only sine is positive. And that's where I'm at, is right there in that quadrant. So this sign has to be positive. So that would be my answer for that question. I can do one more if you want. Let's do this one. The tangent of 7 pi over 6. Okay, so if you do 7, 6 pi times 180 over pi, you multiply all that out and you get 210 degrees. So the tan of 7 pi over 6 is the same as the tan of 210 degrees. So to find where 210 degrees is, this one's positive this time, so I'm coming up this way. 90, 180, 210 would be right here. And this part is my reference angle. So if I subtract 210 and 180, that gives me 30 degrees. So it's tan of 210, which is the same as the tan of 30 degrees, with an accompanying sign change if you need it. Tan of 30, look on my chart right there. So my answer is root 3 over 3. All I have to do now is figure out what the value of tan is in this quadrant right there. So I look on my cast thing. Here's my quadrant over here. It says tan's positive in that quadrant, so my answer is positive. One last question, and I'm not going to do this one. These are cofunction identities, and we're not going to do any kind of identities in Math 32. That's a Math 30 kind of thing. So don't worry about those. All right, hopefully that helps you.